Welcome. In this video, we are going to discuss bivariate normal distribution and some problems related to it. Okay. So the joint density of bivariate normal distribution is given as 1 upon 2 pi sigma x sigma y under root of 1 minus rho square exponential of minus 1 upon 2 times of 1 minus rho square multiplied with x minus mu x upon sigma x whole square minus 2 rho times of x minus mu x upon sigma x multiplied with y minus mu y upon sigma y plus y minus mu y upon sigma y whole square. Okay, here this rho is the correlation coefficient of these two variables, that is covariance of x comma y upon sigma x sigma y, right? And this covariance of x comma y, this is expectation of xy minus expectation of x and product with expectation of y. Okay, here x and y are normal random variables with mean mu x and variance sigma x square, and similarly y is normal random variable with mean mu y and variance sigma y square. Okay, and remember if x is a normal variate and y is a normal variate, then x plus y, or simply alpha x plus beta y is also a normal variate, and the mean and variance will be differing, that we can find it out. But the thing is that if x and y are normal random variate, then their linear combination is also a normal random variate. Okay, we have a problem here. Here the question tells us that a college professor has noticed that scores of two tests follow a bivariate normal distribution with 5 parameters. So if we look back the definition, here it is involving 5 different parameters, and all these parameters are given to us. If a student receives a score of 80 in the first test, what is the probability that he will do better in the second one? So, given that he has scored 80 in the first test, okay, and he needs to score more in the second test. So, we are going to calculate the probability. Okay, so this is following a normal distribution now. Okay, so with some mean mu star and variance sigma star square. Okay, this is calculated using this. So mu y plus rho times of this formula, through which we just calculate this mu star and this sigma star. Okay, and substituting the given values into these two formulas, we finally calculate the value of mu star to be 86.833 and sigma star square to be something like this. So he is scoring more than what he has scored in the first test, which means more than 80. We need to find it out. So for this we have this. We just standardize it. Okay, we get it, and from the table we calculate this value. Okay, only this thing we'll have to do it. So all we need to do is to find out this mu star and sigma star square and just calculate the remaining things. That's it. Okay, now the question is, how is the answer affected if rho is minus 0.85? Okay, initially it was 0.85. Now instead of this plus 0.85, we will have to replace it with minus 0.85. We calculate mu star and sigma star accordingly, and we just calculate it. So if you see, when rho was 0.85, the chances were high, whereas If it was less, the chances were less. Okay, moving to the next problem. This doesn't concern binomial bivariate normal distribution, but this is something which deals with the transformation of random variables. Okay, and here we are asked to find out the density function of this variable u. Okay, first of all, let us try to find out the uh, distribution function and finally differentiate it to get the density function. Okay, now we will find it out. But we let us try to look for the possible values of this u. Okay, if you see, so from 0 to 4 we have, right, and 1 to 5 we have. So this is 5 and this is 1, and so that is the points. Let me write. So this is the point. X is 0 and y is 1, and here it is 4 comma 1, and this is 4 comma 5, and this is 0 comma 5, right? Okay, our function is x plus 2y. So if it is passing through the corner points of this one, through which only we are going to find out the different values of all are the possible values of y. If it is passing through this point, then this is x plus 2y is what? 2. Okay, suppose if it is passing through this point, then this is x plus 2y is what? X is 0 and y is 5, so it is 10. Suppose if it is passing through this point, this is x is 4 and this thing, so it should be x plus 2y is 6. So the diagram that I drew is something slightly different, so it should be the other way. Okay, and this is x plus 2y is 4 plus 10, which is 14. Okay, so you will take the values from 2 to 14, but it is split in 4 different things. That is from 2 to 6, okay, then 6 to 10, and 10 to 14, and below 2 and above 14. These are the possible values, right? So now for u between 2 and 6, what is going to happen? Okay, that is probability of x plus 2y, which is above 2 and smaller than 6. So this is what we are going to calculate. This is x is going to differ from where? It is given 0 to 4. Okay, and y is going to differ from 0 to u minus x we have fixed, which means x is going to differ from u minus 2u, right? Suppose from this you can write either x is u minus 2u. This is one way, but here we are fixing x value to vary from 0 to 4. Okay, so which means y has to be written in terms of u, that is u minus x upon 2. Okay, and this thing whatever you have, you just have to integrate and you will get some value. Okay, and for the other case, okay, here you just draw one line and see how it is functioning. Okay, and for the next cases, you lying between these two things, that is probability of x plus 2y less than or equals u. Again, if you see it, you have the same thing. Okay, and sorry, y is running from 1 to this thing, u minus x upon 2, and the same thing we will have for the other case, that is from 10 to 14. You have the same stuff, but here your this thing is going to differ from u minus 10 to 4, and y is going to differ from 1 to u minus x upon 2. Okay, at last everything will be some function of, you will have some function of u. Okay, this constitutes the distribution function. Okay, let me repeat it here. The function is x plus 2y. Okay, you need to find out f of u. This is what you are asked to find out, but we know that derivative derivative of distribution function is the density function. We try to identify the distribution function. So distribution function means from 2 to 6. Okay, actually this line passes something like this, then this line passes, this is your x plus 2y is 10. Okay, so we have something like this. So first of all, we try to find out the probability in this region, that is this one. Next we try to find the probability in this region. Okay, then in this region. So this is how we calculate. So all you have to do is to use your calculus ideologies here. That's it. Okay, just perform it and calculate its value. You will have some values, right? Moving further, here we have a joint density. We are asked to find out the covariance and correlation coefficient. Okay, let us see how do we do it. First, let us calculate the marginal densities. So if you calculate it, it is from 0 to 1 minus x, isn't it? 2 times of dy, it is going to be 2 times of 1 minus x. In a similar way, if you calculate the marginal density of y, it is 2 times of 1 minus y. Okay, and it is in the interval 0 to 1, and it is in the interval 0 to 1 again. Now, what is fx of x? Okay, sorry, this one is found. Now, let us calculate e of x, that is integral 0 to 1 fx of x dx. If you calculate it, we get it as 1 upon 3, which is same as that of expectation of y. Now we will calculate expectation of xy, that is integral 0 to 1, okay, and integral 0 to 1 minus, you can fix it. Now you are free to fix it. It can be either 1 minus y or 1 minus x. So it is 2 times of, okay, sorry, xy times of multiplied with 2 dx dy. If you just integrate it, you would get 1 upon 12. Okay, now what is covariance of x comma y? It is expectation of xy minus expectation of x product with expectation of y. So this is 1 upon 12 minus 1 upon 9, which comes out as minus 1 upon 36. We found the covariance. And this is covariance of x comma y divided by standard deviation of x product with standard deviation of y, for which we calculate this expectation of x square. So if you just do it, that is x times of 2 times of 1 minus x dx, and So this way you will calculate this one, and variance of x is expectation of x square minus mu x square. So this value comes as 1 upon 18. This value is same as that of variance of y. Okay, and substituting these values in this, you get this correlation coefficient as minus 1 upon 2. So here all you need to do is to perform some calculations. Okay, next we have another problem. X and y are given as some joint normal random variables with the respective parameters are given. We are asked to find out the probability that x plus y is greater than 0. Since x and y are normal, x plus y is also normal. Okay, then we need to calculate the mean and variance of this one. Okay, how are we going to calculate it? Using the law that expectation of u is expectation of x plus y, which is nothing but expectation of x plus expectation of y. That is what? Simply sigma x plus, sorry, mu x plus mu y. That is minus 1. Okay, and variance of u is variance of x plus y. That is nothing but variance of x plus 2 times of covariance of x comma y plus variance of y. We know that rho is covariance of x comma y upon sigma x sigma y. If we need only this thing, if we need covariance, it is rho times of sigma x sigma y, right? Isn't it? If we just substitute these values, we get variance of u as 53. Approximately it is 53. So we say that this u is a normal variate with mean minus 1 and variance 53. Okay, and we just standardize it and see the probability value. Okay, once you have the mean and variance or standard deviation, you can normalize it and find the value. In the next part of this problem, we are asked to find out the constant a if this ax plus y and x plus 2y are independent. Okay, as I said as I said before, if x and y are normal, then the linear combination is also normal. Okay, therefore this ax plus y and x plus 2y are normal. Okay, now to say these two are independent, it is enough to say that the covariance is 0. Okay, now we just expand this covariance. Okay, so expansion in the sense covariance of ax plus y comma x plus 2y, this can be written as this a times of covariance of x comma x plus 2a times of covariance of x comma y plus covariance of y comma x plus 2 times of covariance of y comma y. Okay, so and what is this covariance of y comma y? It is simply sigma x square, sigma y square. Okay, similarly covariance of x comma x is sigma x square. So using this, we just calculate and equate this to 0 and find out the value of a. Okay, so from which we calculate the value of a, that is minus 16 upon 47, right? And we move further to calculate all these things. Again, if you see, this is a linear combination of normal variate, so this should be a normal variate. Again the same. So using the same calculations, we find out, supposing if we take this as u, okay, u is x plus y. Okay, and let us take v is 2x minus y. For this u, we have calculated the mean and variance already. Now that we need to calculate the mean and variance for this v. Okay, using the same ideology, if we just calculate it, we get the mean and variance value. So now that we have the values of mean and variance for this v, okay, now we have the values of these two things through which we calculate the value covariance of these two things, and hence we find the rho value. Now that we find the expected value, the conditional expectation value and the variance value. Once you have this values, just standardize it and solve the remaining things. Okay, that's it. Thank you.